Okay, let's practice these two strategies for working out what curve we're looking at from a set of parametric equations. So here, this is number 10 from the book, and we have x is equal to t squared and y is equal to t cubed. Let's start by plotting points. I'm going to make a little chart that has time, x, and y. Okay, so when t is equal to -2, then x is equal to 4, and y is equal to -8. When t is equal to -1, then x is equal to 1, and t is equal to -1. When t is equal to 0, x is equal to 0, and y is equal to 0. When t is equal to 1, x is equal to 1, y is equal to 1. When t is equal to 2, x is equal to 4, and y is equal to 8. Okay, so we notice a couple of things here. We notice that our x values are always positive, while our y values are both positive and negative. And if we go to plot them, so we have our x-axis and our y-axis. So let's get started. So we have 4, -8. So maybe somewhere down here. And we have 1, -1. Well, we covered a lot of ground. One, -1, and then 0, 0, and then 1, 1, and then 4, 8. And now we can see one of the things that makes just plotting a little bit difficult is that it's hard to tell how to join these things together, right? We can see that the particle is moving quickly from time -2 to time -1, and quickly from time 1 to 2. But it's kind of hard to see how we should finish filling these guys in, right? Should it be like this, or like this, or like this? But it does give us a good sort of starting point. Okay, let's also try substitution. So we're going to get rid of the variable t. Okay, so for substitution, we want to get rid of this variable t. Okay, so for instance, one thing we might do is we could get rid of it by saying, well, x is equal to t squared, and y to the 1/3 is equal to t. Okay, so that means that x is equal to y to the 1/3 squared. Or y to the 2/3. Now we can leave this expression as it is, or we can say, well, y is equal to x to the 3/2. Well, but since we're taking square roots, we want both of these both the positive and the negative square roots. Okay, so that means that we would want to plot x to the 3/2, but we want both the positive and the negative branches of this. Okay, so what does this guy look like? Well, x to the 3/2. This looks like this. Okay, and then we also have the negative branch. So like this. Oops. Okay, I'm going to just draw it quickly over here. Maybe that will help clean it up. So it looks like this, kind of like a K. All right, so it looks something like this. Okay. One piece of information that we lost in the substitution method that we had in the plotting points method was the idea of the direction of this particle's motion. So here we can add in arrows showing how the particle is moving. Okay, so we start down here with very negative values of y. Our y values approach 0, and then get large